Hi everyone, I am Dr. Mamta Gaur and I will be taking your Statistics and Computer Application course for PhD coursework. The major contents in this particular course you are going to study are hypothesis design, null hypothesis, alternate hypothesis, parametric and non-parametric tests, hypothesis testing using Z-test, T-test, analysis of variance, that is ANOVA, degree of freedom, confidence interval, Kolmogorov-Smirnov test, run test for randomness, Mann-Whitney U-test, K-sample test, that is Kruskal-Wallis test, testing of hypotheses concerning means and variance. We will also study chi-square test, charts and tables, correlation, regression, properties of regression coefficient, curve fitting, least square method, classical assumption of linear regression model. We will also be studying in this course Gauss-Markov theorem, properties of the estimators, problem of prediction, multiple regression analysis, that is notation and assumptions. Then under computer application, you will be studying introduction to spreadsheet application, that will include features and functions, formulas for statistical data analysis. Apart from that, you will also study generating charts, graph, and other features of MS Excel. We will also study the use of software for statistical analysis such as SPSS, R, MATLAB, LaTeX, AMOS, and if any other is required, then also. Hypothesis design. This refers to the process of formulating a clear and testable statement, which is known as hypothesis. This proposes a potential relationship between variables or phenomena. In scientific research, hypothesis design is a crucial step in the scientific method, which involves developing and refining hypotheses based on the existing knowledge, observations, and theories. The process of hypothesis design typically involves the following steps. The first step is to identify the research problem. So, in this step, we clearly define the research question or problem which one want to investigate. This helps to provide a context for developing our hypothesis. Second step is literature review. Review existing research and literature related to your research problem. So, this step helps you to understand what is already known from the topic and informs the development of your hypothesis. Next step is to formulate a hypothesis. So, based on the research problem and the literature review, we can propose a clear and testable statement that will predict a potential relationship between the variables. A hypothesis typically consists of an independent variable, that is the factor which we want to manipulate or measure, and an independent variable, that is the outcome which we want to measure. So, broadly categorizing the hypothesis, we can categorize them into two categories. One is the null hypothesis, and the other is the alternate hypothesis. So, in this step of dividing the hypothesis into two categories, we can depict null hypothesis by H0 or HO, and alternate hypothesis by H1 or HA. The null hypothesis suggests that there is no significant relationship or effect, while the alternate hypothesis proposes a specific relationship or effect. Next step is to specify the variables and the predictions. So, in this step, we have to clearly define the variables which are involved in our hypothesis and outline the expected outcome or the result if the hypothesis is supported. Now, next step is to operationalize the variables. So, this describes how we will measure or manipulate the variables in our hypothesis. This step is very important for ensuring that our study is replicable and the variables are clearly defined. Next step is to select the research methods. So we have to determine the research methods, the experimental design, the data collection techniques, and the statistical analysis which we will be using to test our hypothesis. Now, next is to collect the data. In this step, we conduct experiments, surveys, observations, or any other data collection method which we are going to use to gather the relevant information according to our hypothesis. Then after collecting the data, we need to analyze the data. So we will apply appropriate statistical methods to analyze the collected data and determine whether the results support or reject the null hypothesis. So once the data is analyzed, we need to draw conclusions. So that is the next step. So based on the analysis of our data, we make conclusions and whether the result align with the predicted relationship proposed in our hypothesis or not. After that, we will discuss the implications. So, interpret the significance of our findings in the context of the existing research, theories, and the practical applications. Here, we will discuss how our results contribute to the broader field of study. Now, the last but not the least, the step includes revision and refining of our hypothesis. So, if our hypothesis is not supported, considering revising or you can say refining your hypothesis design. We may have to even revise the research method, variables for future studies, and etc. So, now we can conclude that overall, hypothesis design is a systematic and structured approach to formulating research questions, establishing relationship among the variables, and testing these predictions through empirical investigation. It is a fundamental process of inquiry and critical for advancing our understanding of the natural world. Now let's discuss the hypothesis in detail. As we all know that scientific processes or all empirical sciences are recognized by two interrelated concepts. That is context of discovery, that is getting an idea. The second one is context of justification, that is the testing and the results. So hypotheses are the mechanism and container of knowledge moving from unknown to known. These elements form techniques and testing ground for scientific discovery. Hypotheses are tentative explanation and potential answer to a problem. Hypothesis gives the direction and helps the researcher interpret data. So in this topic, we will be familiarized with the term hypothesis and its characteristics. Just defining it again, we can say that hypothesis is an unproven proposition or possible solution to a problem. So, hypothetical statements assert probable answers to research questions. A hypothesis is also a statement about the nature of the world and its simplest form, it is a guess. So, a hypothesis is a suggested explanation of a phenomena or reasoned proposal suggesting a possible correlation between multiple phenomena. This term actually is derived from the ancient word hypotheniai, meaning to put under or to suppose. So the scientific method requires that one can test a scientific hypothesis. So scientists generally base such hypotheses on previous observations or on extensions of scientific theories. If we see from point of view of evaluation, we can say that hypothesis refers to a provisional idea which needs to be evaluated. So for proper evaluation, the framer of a hypothesis needs to define specifics in operational terms. So a hypothesis requires more work by the researcher in order to either confirm or disapprove it. So, in due course, if a confirmed hypothesis may become part of a theory or occasionally may grow to become a theory itself. Normally, Scientific hypotheses have the form of mathematical model. So sometimes, but not always, one can also formulate them as existential statements, stating that some particular instance of the phenomena being studied has some characteristic and causal explanation, which have the general form of universal statements. So, stating that every instance of the phenomena has a particular characteristics. Any useful hypothesis will enable predictions by reasoning. So, in this, we may include deductive reasoning. It might predict the outcome of an experiment in a laboratory setting or the observation of a phenomena in nature. Let me share some tentative hypotheses. Now, the problem statement and hypothesis may be similar, but while evaluating a hypothesis, research management should make sure the information collected will be useful in decision making. So, we can make note of some of the hypotheses. There is a positive relationship between the mail order, catalog buying, and the presence of younger children in the home. Another hypothesis can be voluntary turnover, that is, the quitting, will be higher among employees who perceive themselves to be inequitably paid than among employees who perceive themselves to be equitably paid. Another example is like common stocks bought at high dividend yields will afford lower average returns than securities bought at lower dividend yields. So here we can see both state relationships, but problem statements expressions are interrogative and hypotheses are declarative. Sometimes they are almost identical in substance. An important difference, however, is that hypotheses are usually more specific than problem statements. They are usually closer to the actual research operations and testing. So, hypotheses are statements that can be empirically tested. Now, looking to the characteristics of a good hypothesis, as we have already studied that hypothesis is a testable and tentative statement of the possible relationship between two or more events or the variables under the investigation. So, in order to be useful in any study, the hypothesis needs to be stated in such a way that it might be subjected to empirical testing. So here the researcher will be responsible to suggest or find some way to check how the hypothesis stands against empirical data. So when formulating a hypothesis, we must determine the usefulness of the formulated hypothesis. Now, how to determine this usefulness? There are various criteria or the characteristics which we can see in our hypothesis. If the hypothesis is meeting those criteria, we can say that it is a good research hypothesis. Otherwise, we may say that it is not a good research hypothesis. So let me just brief out what are those criteria. Hypothesis should be conceptually clear. That means the writing part, the declaration part should be very clear. Hypothesis must be testable. That means enough number of tests should be applied on that. Hypothesis should be related to the existing body or theory and impact. Hypothesis should have logical unity and comprehensiveness. Hypothesis should be capable of verification. And last but not the least, hypothesis should be operationalizable. While formulating the hypothesis, we need to keep few things in our mind. As we proceed with the hypothesis formulation and then testing it, we know that the testing of the hypothesis through various statistical tests may lead that hypothesis is either accepted or rejected. So if the hypothesis is accepted, then researcher can replicate the results. If hypothesis is rejected, then researcher can refine or modify the results. So, by stating a specific hypothesis, the researcher narrows the focus of the data collection effort and is able to design a data collection procedure which is aimed at testing the plausibility of the hypothesis as a possible statement of the relationship between the terms of the research problem. So, it is always useful to have a clear idea, vision about the hypothesis. It is essential for the research question as a researcher intends to verify, as it will direct and greatly help to interpretation of the results. So now this topic will be followed by the types of the hypothesis, which is the null hypothesis and the alternate hypothesis. Possible difficulties in formulation of a good hypothesis. There are three major possible difficulties. Number one, a researcher could face during formulation of hypothesis is the absence of knowledge of a theoretical framework. Now, second one is if detailed theoretical evidences are not available, or if the investigator is not aware of the availability of those theoretical evidences, a research hypothesis cannot be formulated. Third, when the investigator is not aware of the scientific research techniques, he or she will not be able to frame a good research hypothesis. Now, despite of these difficulties, the investigator attempts in his or her research to formulate a hypothesis. Usually, the hypothesis is derived from the problem statement. The hypothesis should be formulated in a positive and substantive form before data are collected. In some cases, additional hypotheses may be formulated after collection of data, but they should be tested on a new set of data and not on the old set which has suggested it. The formulation of a hypothesis is a creative task and involves a lot of thinking, imagination, and innovation. As we know that there are two types of hypothesis, null and alternate hypothesis. So, the formulation of the null hypothesis is a very vital step in testing significance of the statistics. Now, having formulated such a hypothesis, which we call it as null, one can establish the probability of observing the obtained data or the data more different from the prediction of the null hypothesis. That, but subject to condition is that the null hypothesis is true. The probability, what is commonly called significance level of the result. In formal terms, the null hypothesis is a statement that represents the absence of a specific effect or relationship. Just to make you through few examples, like in a drug trial, the new drug has no effect on blood pressure. This is the null hypothesis, while the alternate can be there is significance effect of drug on the blood pressure. Like suppose if we are doing a study in education, we can say that there is no difference in the test scores between group A and group B. But our alternate hypothesis can say that there is a significant difference in the test scores between the group A and B. Suppose if we are doing a marketing study, we can say that the advertisement has no impact on consumer purchasing behavior, while we want to prove that advertisement has significant impact on the consumer purchasing behavior. So the researchers collect the data and perform statistical tests to determine whether the evidence supports the null hypothesis or suggests that there is a significant effect or difference. If the evidence strongly contradicts the null hypothesis, the researcher may reject it in favor of an alternate hypothesis, which suggests that the presence of a specific effect or relationship is there. So it's important to note that failing to reject the null hypothesis does not necessarily mean that the null hypothesis is true. It simply means that there isn't enough evidence to conclude otherwise based on the data collected. The concept of the null hypothesis is a critical component of the scientific method and helps the researchers to make objective and evidence based conclusions about the phenomena they are studying. Let's discuss more about the null hypothesis. As I have already discussed with you, it is denoted by H0. It is a fundamental concept in statistical hypothesis testing, and it represents the idea that there is no significant difference or effect or relationship between the variables or phenomena under investigation. The null hypothesis is typically a statement of no effect or no difference and is used as a starting point for the statistical analysis. Null hypothesis is generally that which is presumed to be true initially. Hence, we reject only when we are quite sure that it is false, often 90, 95, or 99% confident that the data do not support it. For example, if we want to compare the test scores of two random samples of men and women, a null hypothesis would be that the mean score of the male population was the same as the mean score of the female population. So here we have H0, that is M1 is equal to M2. That is the mean score of the population 1 is equal to the mean population of 2, where H0 is the null hypothesis and M1 is the mean population of the first population, that is the male, and M2 is the mean population of the second group, that is the female. So, alternatively, the null hypothesis can postulate that two samples are drawn from the same population so that the variance and shape of the distributions are equal, as well as the means and variance are also equal. Limitations of a null hypothesis. A null hypothesis is only useful if it is possible to calculate the probability of observing a data set with the particular parameters from it. In general, it must be harder to be precise about how probable the data would be if the alternate hypothesis is true. If experimental observations contradict the prediction of the null hypothesis, it means that either the null hypothesis is false or we have observed an event with very low probability. This gives us high confidence in the falsehood of the null hypothesis, which can be improved by increasing the number of trials. However, accepting the alternate hypothesis only commits us to difference in observed parameters. It does not prove that the theory or principles that the predicted such a difference is true, since it is always possible that the difference could be due to additional factors not recognized by the theory. For example, the rejection of a null hypothesis, that is, say, rate of symptom relief in a sample of patients who received a placebo and sample who received a medicinal drug will be equal. Now, allows us to make a null hypothesis or the statement that rates differed. It does not prove that the drug relieved the symptoms, though it gives us more confidence in that hypothesis. The alternate hypothesis, as already we have discussed, it is denoted by H1 or HA. So it is a very major key concept in statistical hypothesis testing. It represents a statement that contradicts or opposes the null hypothesis, that is H0. In other words, the alternative hypothesis suggests that there is a significant difference or effect or relationship between the variables or phenomena under investigation. The alternative hypothesis is the researcher's specific hypothesis or the effect they are interested in detecting. It states what the researcher hopes to find evidence for based on the data collected and analyzed. Unlike the null hypothesis, which assumes no effect, the alternative hypothesis proposes a specific effect or relationship that the researcher believes is occurring. In formal terms, the alternative hypothesis is often stated in a way that reflects the researcher's expectations or predictions. Example: in drug trial, the new drug has a significant effect on reducing the blood pressure. In an educational study, there is a difference in test scores between Group A and Group B. In a marketing study, the advertisement has an impact on increasing consumer purchasing behavior. So, researchers collect the data and perform statistical tests to determine whether the evidence supports the alternative hypothesis. If the evidence is strong enough, the researchers may reject the null hypothesis in favor of the alternative hypothesis, indicating that there is a significant effect or the difference present in the data. So it's important to note that the choice between the null hypothesis and the alternate hypothesis depends on the research question and the researcher's expectation. The alternative hypothesis is a central element of hypothesis testing, helping researchers to draw conclusions and make inferences about the phenomena they are studying based on the empirical evidence.